Okay, so far we've used SOHCAHTOA to solve all right triangles, and now we're going to bring in triangles that aren't right anymore. And there's going to be two ways to do these. And one, it's called law of sines. That's what we're doing today. And then we're going to use an S side angle side formula to get the area of a triangle, because there are so many different ways to find the area of a triangle, depending on what you're given on it. We've always used 1/2 base times height, right? Well, we are going to be using more formulas to find areas of triangles, because sometimes you may not know the parts you know. To give you an example, my wife's uncle lives down in Brown County, and they have a law down there by where he lives that you have to have 10 acres of land in order to build a house on it. You have to own 10 acres of land. And he had this land, and he wasn't sure how many acres were on it, and it was in the form of a triangle. And all he knew was side, angle, side. He didn't know anything else. He knew two sides of the property and the angle between those sides. So I actually used this formula I'm going to give you in a little while to find the area of his land, and then I used the area to figure out how many acres there were. And you know what? It was bad news for him, because it was only 8.9 acres. So he could not build a house on it. So it would have been more important for him to know that before he bought the property, to know that he couldn't put a house on it, then he wouldn't have paid the money for the property. But anyway, so law of sines, side angle side to get the area. We're going to use that today. Tomorrow you do not want to miss, because there are some times when you do law of sines, there's one case where there's going to be two triangles that are possible. Okay, it's called the ambiguous case, and it's challenging. But we're not going to mess with the ambiguous case till tomorrow. All right. So we are going to be dealing with triangles that are not right, so I made up this triangle. And every triangle, we let the vertices be A, B, C, capital letters, and the sides opposite those capital letters are the lowercase of those capital letters. We let those be that side. And the law of sines says this. Law of sines says that the sine of an angle is ratio to the side opposite that angle, as the sine of every other angle is to the side opposite of that angle. Now, whenever I am going to find a missing angle, when I am looking for the angle, I'm going to use this formula. Now, I hope you all know that if we have, if I had fractions up here that are equal, if I have fractions that are equal like this, all those would reduce. That's supposed to be a 3, by the way. All those would reduce to a half, right? And if you flip a fraction upside down, all of the fractions upside down, all of these flipped upside down are still equal. They're all equal 2, right? So I put the angles on top when I'm looking for the angle, or when I'm looking for a side, I put the sides on the top. So it depends on what I'm looking for as to what I put on top. And the reason being is it makes the math easier. Some teachers only teach this bottom row. I'm going to teach the top because it makes the problem easier. You get all this down? Without your pen, you just put it in your photographic memory, huh? That's pretty amazing. Scott Gibbons at Purdue had a photographic memory, but he proved it to me. I haven't had anybody in here prove to me they have that. I wish they did. So we're going to use these things to find it. All right, so we are doing, 5 to 21 odds, I think? Yeah, 5 to 21 odds today in your book. So somebody pick a problem on 5 to 21 odds on it that I just passed out to you, and we're going to do that problem. 13. Number 13. We're going to do number 13 together. And the directions on 13 say, using law of sines, solve your triangle. Now this says round your answers to do 2 decimal places. I want you to take, now write this down on that paper I gave you, round your angles to the nearest minute, because that's what we're going to do on the test. Round your angles to the nearest minute, so we got to use the DMS button. And we're going to round the sides to the nearest 1,000. How many decimal places is that? 3 decimal places. So we're not going to follow the rules of the book very well. We're going to do it a little more accurately than the book's telling us. All right, so problem number 13 says angle A is 35 degrees. Angle B is 65 degrees. And side C is 10 units, whatever it is, inches, meters, feet, I don't know, doesn't matter. So we have this, look, now, 90-some% of us are visual learners, so I would recommend that you draw a picture, and the picture does not have to be accurate at all. I mean, I just want you to take a look at what we know. So we know this angle is 35 degrees. We know this angle is 65 degrees, and we know this side is 10. So if I were doing this problem, and I was talking about angles and sides, did you guys remember doing congruent triangles? What would you say you were given on this picture? Remember doing side, congruency, side, angle, congruency, angle, side, congruency, angle, side, angle, congruency, hypotenuse, leg, congruency, and triangles in geometry? You guys just had geometry last year, right? Okay, some of you had it last year, some a couple years ago. Anybody tell me what I'm given on this picture by where the angles are given to you? What's that called? Anybody know? Yeah, this is angle, side, angle, because do you see this side 10 is between those two angles? Now tomorrow that's going to be important because there's one case when you're given side, angle. When you're given side, angle, you might have two triangles, and that's the only time you ever have to worry about it. So we only have one triangle here we have to worry about. Anybody here tell me why do I love math? Rules never change. So you know all the rules you learned in algebra, algebra 1, algebra 2, pre-algebra, geometry, do they still apply in this class? They apply for the rest of your lives unless you take something called taxi cab geometry. It's a different total thing. We talked about it earlier in the year. I don't know if you remember or not. It's about how they give bus routes, taxi routes, all those things through cities, because you can't go through the blocks where that buildings are, right? So there's taxi cab, and then when you're doing a geometry in space, these rules don't apply in space. They just apply in areas on the earth. So anyway, whenever I'm giving two angles, I will never use SOHCAHTOA to find the third angle. Anybody tell me what we should always do to find the third angle? Yeah, the triangle sum theorem says all three angles in triangles always add up to what? They always add up to 180. Now that's not true in space, okay? But for our geometry, which is called plane geometry does not mean regular old geometry. Plane geometry means flat surfaces like your desktop. That's what a plane means in this class. So in this class, you're right. I would always find if I got two angles, I always know that one angle plus another angle plus the third angle is always going to equal 180. That is called the triangle sum theorem from geometry class. So never do it at law of science to find the third angle because this is faster. So any rules you've ever had, you can apply to this. I know them. So you can apply them. You can't make up new ones. So I don't know if you guys, what you do, but this is 100 plus angle C. And then you would subtract 100 from both sides. So you would get, and usually in math class, and you should have learned this before, sometimes they put a little m in front. Does anybody know what that little m means? A measure of angle C is 80 degrees. So there's angle C. And by the way, we've got three things to find. We got this angle to find, we have this side A to find, and we have this side B to find. We're going to find all of them. Am I going too fast? You getting all this down? I'm doing a homework problem for you. Okay, there's three answers you're looking for on all these. Okay? So to find all the missing parts. Now, I don't have a right triangle, do I? So I know this side down here is 80. 80 degrees. I said side. That angle down there is 80 degrees. And now I want to find A or B. Okay? Now whenever I'm finding a side, I want it to be on the top. Remember me writing that earlier? I gave you that if I'm looking for an angle, If I'm looking for angles and I've only got one angle, I use this stuff. If I'm looking for sides, which I should have put over here, if I'm looking for sides, I use this. I put the sides on top. So I'm looking for a side, and I got to pick a side. Which side do you want to find first? And it does not matter. We're going to find B first. So we're going to say B is to the sine of angle B. I guess I'm going to do this first. And you must always use the side and angle they give you. So they gave us the 10, and we know the 80 is perfect. So I'm going to use little c is to sine C. I know 80's got to be perfect because I know these three have to add up to this. So I want to use the angle and side they give me each time. So I'm going to get little b is to the sine of 65 as 10 is to the sine of 80. How many are thumbs up to where I plug those in from? I want to see everybody's thumb up or down, because if anybody's down, we're going to do it again. You up or down? You sure? Over here, I got to get you guys on the far side. Michelle? Okay. You don't know where the numbers came from, right? Okay, do you remember up here they gave us this stuff? And I just found angle C is 80, and I know that's got to be perfect, so that I'm going to use two of the three, and I have to use the one given to me. So if you look, the one given to me that has an angle and a side opposite are these two. I know those two are set, so I must use the 10 and sine 80. And somebody said they wanted to find B first, so we're going to look for B, and the side opposite of B is or the angle opposite of B is angle B 65. So I put 65 in for B, I put 10 in for little c, I put 80 in for big C. Thumbs up where it all came from. Everybody? All right, now we're going to do algebra. I want to get little b by itself, so what do I got to do to get rid of a denominator? Anybody? I got to multiply that bottom piece over. So that means little b is going to be 10 sine of 65, because I'm multiplying this over here to this side, all over the sine of 80. Now I have to get out my calculator. So your calculator's got to be in what kind of measurement? Can't hear you. Degrees. So make sure your mode's in degrees. And then we're going to type this in and round it to how many places did we say? We're going to round it to 3 places so I can see this thing down there. So let's see, my mode is in radians, so I got to change it to degrees. Now I'm going to type that in. So I'm going to hit alpha y equals 1. I'm going to get 10 sine 65 divided by sine 80. So there's my answer. So the 3 places, we're going to call that 9.203. Hey, what's the back of the book going to say about B? What's it going to say? Anybody know when you check it? What did directions say to do? It said to 2 places, I think, right? So it'll say 9.20, but we're going to go to 3 places. How many? Yes. Okay. If I was solving an algebra problem that said x over 2 equals 8, right? We want to get x by itself. We take this side times 2. We take this side times 2 because these reduce to get x all by itself, right? Well, it's the same thing over here. I am taking this side by sine of 65 and this side by sine of 65 so that these reduce out because my goal is to get b by itself. Does that get that question answered?
No, because what happens to the other side? Why would you do sine 65 to the bottom?
Okay, because when I'm multiplying sine 65 to reduce with the denominator, it has to be in the numerator. Because when you reduce fractions, they have to be in the top. Just like this 2 has to be in the top, so that 2 has to be in the top. So I have to keep the sign in the top because this sign to reduce with the denominator has to be in the numerator. Is that cleared up? Anybody else got a question? Okay, so that's B. So this B is done. You are not allowed to use the B's anymore because we rounded that answer. And if you keep rounding answers, you keep getting further and further away from the accurate answer. So we must use the highlighted green again because that's what's given to us. That one doesn't change. It's perfect. So now I need to find what else? I got to find side A. So I'm going to use B again because B is the one that's set in stone. It's exactly right. I didn't round it at all. And I'm still looking for a side, so I got the little letters on top. And now I'm going to plug in, I'm going to use these two in order to get little A. Yes?
C is the one that's highlighted. Yeah.
Oh, you're right. It is C. Thank you. I wrote the wrong letters down. You got that right, Haley. Good job. Okay, so C's are the ones that are highlighted. So I'm going to put 10 in here again. I'm going to put sine 80 down here again. And over here, a little a is what I'm looking for. And I know angle A is 35 degrees. So just like getting rid of sine 65, what do I got to get rid of to get little a by itself? Sine 35. So I'm going to multiply it over to the top part. And now I got to get my calculator out again, and I'm not going to show this one on the screen, but I'm going to type that into my calculator. And you ought to practice it too. Let's see, 10. And when I get done typing that one in, I get 5.824. Now, the back of the book is going to say 5.82, but I want you rounding to 3 places. How many are thumbs up on that problem? No? All right. Now, I want to do one that's only got one angle given to you because those are a little harder. So let's do one more problem. Somebody, is there one that only has one angle given to us and 2 sides?
17.
All right, let's do number 17. So 17 says angle A is 36 degrees. And side A is 8. So you see I got a big A and a little a, so I know I'm going to use these every time. And then little b is 5. So I'm going to draw a picture because, again, I'm going to tell you that pictures, like 90-some% of us are picture-oriented. So we got this deal. Now, tomorrow, this one's going to be a big deal because this is a side-side angle problem. And please don't write that backwards. You'll get us all in trouble. It's always going to be side-side angle, never angle side-side. Okay, do not write angle side-side. I don't want to get in trouble. Side-side angle. If you ever have this, tomorrow we're going to do this problem again, and we're going to check for a second triangle tomorrow, because this might have 2 that works. But today we're only going to solve for the first triangle. So I want to find sides. I got to find, there's one thing I must find first up here because I have no choice. I have to find it first, and I've got these 2. I know I've got to use the A's. What must I find first? Because I got to have side and angles opposite them. Can anybody tell me the thing I have to find first? I got to find angle B first because I got side B. You see it? So since I got side B, I've got to find angle B. So I'm looking for angle B. So what am I putting on top? Anybody? I'm putting my angles on top because I'm looking for angles. So I'm going to use these. Now, you notice I'm putting a variable on up there first. You don't have to write this one down. But I'm just writing it down to show you that the one I'm using are the ones I'm given. I must use this one every time. Sine of 36 over 8 and sine of B over 5. Now I got to get sine B all by itself. So what do I got to do? Algebra days. Anybody? I have to multiply by 5, that's right. So I get 5 sine of 36 on top, all over 8. Now, anybody got a question so far? Now, b is not by itself yet. You see it? It's not by itself. I got to get rid of the sine function. Now, we've done this already this year. Does anybody remember what gets rid of the sine function? What is the inverse operation of sine? Yeah, it's inverse sine. That's where you hit second sine. So what I have to do now, and I'm going to move this equal sign over, is I have to hit inverse sine. I'm actually not typing this in, but I am doing the inverse sine of this side, and I'm doing the inverse sine of this side because the sine and the inverse sine cancel each other out. So what I'm going to end up with over here is the measure of angle B. Now, you don't have to put M if you don't want to. You can just put angle B. But we're going to type this thing into our calculator, and I'm going to show it to you. So I'm going to hit second sine. Then I'm going to hit alpha y equals 1 to get fraction. I'm going to hit 5 sine 36 over 8. Then I'm going to hit enter. Now, that's in what kind of degrees? Anybody remember what that kind of degree is called? What's that dot, that little dot mean? What's that called? Decimal. This is called decimal degrees. Now I have to hit second apse, which is angles, and you'll see number 4. Second apse 4 is DMS that, and I hit enter, and that will change it to minutes, degrees, minutes, seconds. Now, do you see the 11.699 seconds? What does 11 have to be to round that to 34 minutes? 30 or higher. Remember, 30 or higher? So we're going to say that angle B is going to be 21 degrees, 33 minutes. Now, we just rounded that. Everybody okay there? Okay. I am immediately going to find the other angle. I'm immediately going to find angle C. Anybody want to guess how I'm going to find angle C? I'm going to take 180 minus angle A minus angle B. So that's what I'm going to do on my calculator right now with you, so that you can see where this answer comes from. Okay, so I'm going to type that right there in there. Now watch this, because you can shorten it up in your calculator. So we're going to hit 180 minus, and I did not, what was angle A? Was it 36? Minus 36. And I'm going to hit minus again, and I'm going to hit second, the negative down by the decimal point. That's the answer. So that 21 degrees, 33 minutes, whatever right there, that's what's going in for that answer. Then I'm going to hit enter, and it's back to decimal degrees. Okay? And then I'm going to hit second apse 4 again. Hit enter, and that's my other angle. So we're going to round that to 122 degrees in how many minutes? How many minutes? 27, because 48 is greater than 30 or greater. So that we're going to make this 27. Okay, so there's that one. Let's see, this one was 21:33. Got one more thing to find. What am I going to find? I'm going to find C, right? So now I'm finding a side. So when I'm going to find a side, I put the sides up top. And remember, they gave me the A's are set in stone. And we are looking for side C, right? So I put my numbers in. And again, if you don't want to write the formula with the letters, you can go right to what I'm writing down right now. Now, even though I am writing this down as my rounded answer, oops, this should be sine C, sorry. And again, even though I am writing this down as my round answer, I still got the whole answer on my calculator, which is less rounded. So if you look, I'm going to end up getting angle C over here is going to equal, and remember, I'm going to do inverse sine, just like I did a minute ago, because I'm finding an angle. Oh, I made a mistake, people. This is not inverse sine. That is just C. My bad. I screwed up. I do not need to do inverse sine. I'm finding the side, not the angle. So those of you who are going to jump on me, thank you. You're right. All I got to do is type that in. Now remember, I'm going to get my calculator back up here. If you remember on my calculator, I've got the whole answer of that sine, right? So I'm going to use that whole thing so it's less rounded. So I'm going to hit 8 sine. And then I'm going to hit second answer, second negative sign is the answer. That gets the whole decimal in there instead of the rounded one, divided by sine of 36. So side C, the last thing I got to find, rounds to 11.486. And there's the third side. So when you only got one angle, those make it harder. And you're going to find out tomorrow that it's even going to be